In machine learning, there's a sweet spot called Goldilocks learning. A model must be neither too simple nor too complex, just right. This balance determines how well your model generalizes to new, unseen data. Let's look at 3 models trained on the same data. On the left, an underfitted model is too simple, it misses the true pattern and has high bias and high error. In the middle, a well-generalized model captures the pattern with good accuracy. On the right, an overfitted model is too complex, it memorizes noise, fitting every point perfectly on training data but failing on new data, exhibiting high variance. As we increase model complexity, training error drops. But test error tells a different story. It decreases initially, reaches a minimum at the Goldilocks sweet spot, then rises as overfitting begins. When test error climbs while training error falls, overfitting is happening. The gap between these two curves is the generalization error, we want it small. The Goldilocks principle: balance complexity to minimize bias and variance. Too simple equals underfitting with high bias. Too complex equals overfitting with high variance. The goal is the sweet spot, a model that generalizes to